Alright, so you should have a worksheet that looks like this that says parent functions that will be passed out to you. I want you to follow along filling out the parent function and the characteristics with the video. So the first one is constant. And here we have constant y equals 4. And you notice how it is a horizontal line. So it is a constant, horizontal, and it is linear. It's constant because y is always the same value, so it's always horizontal. So in the parent function, y equals, you can put a number or you can put a variable like c and know that you're going to have a horizontal line wherever that c is. Characteristics are that it's linear, and this one neither increases nor decreases. It stays the same. We can also have a constant where it's x equals, and when it's x equals, we have a vertical line. So this is not a function because every input has, or each input has more than one output. So this is not a function. The horizontal is a function because it passes the vertical line test, or in other words, it is each input has exactly one output. So those are the characteristics of constant. They are lines, they are linear, and if it's y equals, it's a function. If it's x equals, it is not a function. Here you have the next one, which is linear. And you're probably used to seeing y equals mx plus b, where m is the slope. It changes the steepness of the line. When m is positive, so for characteristics, you might want to write in characteristics here, when m is positive or greater than 0, it's increasing. It's always increasing. There is never a maximum, there is never a minimum because it's always increasing. When m is negative, it's always decreasing. So when m is negative, it's always decreasing. There is no maximum, there is no minimum, but the line is decreasing, and it is linear. And the b, of course, changes the y-intercept. Next up we have is quadratic. In a quadratic, the equation looks like this. This is standard form. You will see it written different ways, but for right now, you will see it mainly like this. You notice this one we have what's called a parabola. This one we have curved lines. This one we have a minimum. This point, our minimum is right there. If you notice, the a causes the minimum and maximum to change. Look what happens when our a value, or whatever in front of x squared, is negative. When it's negative, we have a maximum. So when a is positive, we have a minimum. When a is negative, we have a maximum. This parabola increases. You can see how it's increasing from negative infinity to the maximum, and then it's decreasing. So it's both increasing and decreasing. So with the quadratic, if a is positive, we have a minimum. If a is negative, we have a maximum. And it is both increasing and decreasing. Next up, we have a cubic function. And a cubic function is to the third power. So that looks like this. And this one, again, we could tell if I put, the L, if it L, or whatever in front of the x, is positive, it's increasing. There is no maximum or minimum. And when L, or the number in front of x, is negative, it's decreasing. So it's very similar to like our linear function, except this is a curved line. So for this one, the characteristics are it's a curved line, it's increasing or decreasing, and it has no maximum or minimum. The next up is exponential. And an exponential looks like this. Normally we have a times b to the x, but I already used a and b, so I just used n and p. Look what happens when we have p is greater than 1. When p is greater than 1, the characteristics are that it is increasing. It's curved and it's increasing. There is no maximum, there is no minimum. It's curved and it's increasing. Look what happens when we have our p-value less than 1. When the p-value is less than 1 and greater than 0, it's decreasing. You can see how it starts up here and it's decreasing. So when the p-value is less than 1 but greater than 0, it is decreasing. There is no max and min. It's decreasing and it's curved line. Next up is absolute value, and if you look, the letter in front of the absolute, when that's positive, we have a minimum. We have two straight lines and we have a minimum. Look what happens when the value is negative. When it's negative, we have a maximum and we have two straight lines. So that's a absolute value, linear absolute value. Square root looks like this, and a square root is curved and it has a minimum. In this case it has a minimum and it is increasing. So there is no maximum, but it has a minimum. It has a smaller value. If it's negative, or the things in front of the radical sign is negative, we have a maximum and it's decreasing and it's curved. So those are the characteristics. Hopefully you are following along and writing those in. The last one is a piecewise. And a piecewise, that is just how it sounds. There are pieces or different pieces in the graph. So there's 1, 2. So this graph has two different pieces. So there are pieces. The characteristics are it could have a minimum, it could have a maximum, it could be curved, it could be a straight line. It depends on what the piece is. So you'll have to look. The characteristics depend on the actual piece. So those are the families of graphs. Again, I hope you followed along and filled out your worksheet.